Alright, so let's go to the front person in each row. And let's get our answer. So, kind of come back again. Mikkel, what did you get if they compounded twice a year instead of just once a year?
$48,010.
Awesome. That's pretty good. They made more than $1,000 by just compounding it an additional time. Alright, second row, do you guys have it?
Yeah.
48,750
Oh, man, I lost it.
and 39 cents.
Sorry, my thing froze. I might have to keep track over here. So what did you say there, Josh? It was 48.
48,754.
Hey, so not bad. You earned like another $740 or so, right? Cool. Allie, what is yours?
49,268.
03. And I got to keep track. So this was quarterly, and yours was monthly, right? So then, Kimberly, yours was weekly, right? What did you get?
49,469.
Awesome. Okay, let's go to daily, Hiram.
49,521.65. But that's 365.25.
Oh, way to be precise. Okay. All right, let's go to now Brandon and Tao. I told them to do it hourly. So what number is that even? How did you get that?
We're not really sure because it's giving us 49,525.
Yeah, no, you're good. 49,529.
Yeah, with 90%.
But what number, how many times is that? That's 365 by 24, which was what?
8,750.
What is it?
8,750.
Okay, so then we said let's go by the minute. So you guys took 365 times 24 and then times 60. So what is that number?
5,25,000. Let me start over. 525,600.
525,600. Woo! That's a lot of times to compound, right? Now, how much extra money do we make off of doing that?
495. Micah, you say the number.
49,532.
53 what?
30.32.
So, did I write that down right? Did you? Does that look right?
Yeah, look right.
So did you even earn an extra dollar here? So guys, what do you see that's happening here? Are you making more money with the number of times that you compound? Yes, but what? It's kind of getting to a point where it's leveling out, right? Right here it almost went up by like that first one, we went up by like almost 1,500, and then this was just like 700, and now it's like not even $1. Okay, so it's kind of starting to flatten out here. Okay, now is this awake now? Okay. What this is getting to, guys, is if we take the number of times something is compounded, and we look at its limit, and we're going to say let's push it higher and higher. So instead of doing it by the minute, what if we do it by the second? What if we just keep compounding over and over again? Eventually it's going to reach a limit. And do you know what that limit is? It's E. Do you remember E? Yeah. What is the approximate value of E? So here's, if ever you're bored and you're like, hey, I want to do something. If you look at this equation here, 1 plus 1 over x to the x, okay? And you say, what is that approaching as x approaches infinity? And so you just follow along it. It's going to approach 2.718. Now, what this means is we now have a way that we can compound continuously. We've talked about compounding quarterly or monthly or daily or by the second. What does compounding continuously mean? Someone just take a guess at it. Go ahead, Allie, what are you thinking?
Compounding or compounding.
So the very moment you make interest, what's happening to it? It's compounded, so you're earning interest off of it. So you're never not earning interest off of your interest. Does that make sense? You're always earning interest off of it. Anyway, what that means is that you're earning the maximum amount of money that you can. Now, our formula for it is actually going to look a lot easier. If I say you're compounding continuously, you're going to use this one right here, APERT, which is just P e to the RT. So your base is going to be e. Kind of like with a natural log, what is the base? That's common log, right? Natural log, your base is e, and here this. So this is called a natural exponential because its base is e. Let me do an example and I'll see if I can get you because I feel like I may have lost you there for a second. Let's do an example here with Latasha. Latasha invests $100 at 8% annual interest, compounded continuously. Now, if you see this compounded continuously, what this means is you're going to use our new formula. What was our new formula? APERT. That one right there. Okay? So what I'm going to do is I'm just going to go and plug in my information. So let's do that. How much money did she start off with? $100. Then I do E. What was her rate? 8%, so 0.08. And how long is she letting it sit there? Well, the first one, it says let's find it for 1, 2, and 7. For the first one, we'll just do 1. Now, you're going to need your calculator on this. Do you guys see where e to the x is? It's right above ln, I believe, right? Okay, so put in your calculator 100, second ln, e to the 0.08 times 1, which we'll keep it as 0.08. How much money does she have after 1 year? What'd you get, Tao?
108.
Okay, so after 1 year, she has $8.32. So what that's kind of telling us is that at an 8% interest rate, she compounded it as much as physically possible, and she earned $8.32. Okay, well let's go to what about 2 years, and then let's do 7 years. So I'm going to split you guys in half. I'm going to say, hey, you guys, you do 7 years, and you guys over here, you do 2 years, okay? Let's just go real quick and figure out what is 2 years and what is 7 years. All right, let's go to my 2 groups. So when you times it by 2, what did you get? Or after 2 years, how much money does Latasha have? 117 point what?
35.
35, awesome. Okay, then 7 years later, what does she have?
175.
0.06. Okay. So this is how you would use compound continuously. If they're compounding for anything besides continuously, you use this formula. But if you see the phrase compound continuously, you use this formula. Okay? Awesome. So then, let me see where we're at in this. We're going to go over 2 more things and call that good. I don't think we're really going to go over annuities as much. We'll just go over these and call that good. Okay, so let's talk about annual percentage yield and comparing those, and then we'll call that good for today. So, Kimberly, can you just read that top paragraph for us?
With so many different interest rates and methods of compounding, it is sometimes difficult for our consumers to compare two different options. For example, would you prefer an investment earning 8.75% annual interest compounded quarterly, or one earning 8.7% compounded monthly?
So let's pause there. You've got 2 options here. The first one, it has slightly higher interest rate, but it's compounded less often than the one that has, than the other one. So what's better? Is it better to have a higher rate or to be compounded more? That's a good question. So how do we answer it? A common basis for comparing investments is to look at the annual percentage yield. What this does is it's the percentage rate that compounded annually would yield the same return as the given interest rate with the given compounding period. It might seem confusing. Let's talk about it. So basically, when I was looking at these 2 right here, the first one, it had a rate of, what was it? It was 8.75, and how often was it compounded? Quarterly. The second one, it was just 8.7, but it was compounded monthly, so 12 times. Well, when you look at the APY, what it does is it just tells you what the rate would be if it was compounded annually. So we're going to do some little manipulations here, and it's going to just basically say, this is what this rate in compounding would be if it was just compounded annually. Okay? We'll do some practice to make some sense of that. Alright, so now let's talk about this. Ursula invests $2,000 with Crab Key Bank at 5.15 annual interest compounded quarterly. What is the equivalent APY? Well, we need our formula for that. Why? I didn't put your formula in here. That's not cool. Hold on 1 second. Must not have copied over from my other one, so give me 10 seconds. Hold on. There's your formula. Is that not written in your notes? That's not. Okay, so write that in your notes. 1 plus r over k raised to the k minus 1. And you know what? I'm just going to let you use these notes because they're already up there. Cool, huh? Okay. So what we're doing here, if we're trying to figure out what the APY is, well, don't copy it down. We'll work it out together, okay? We're going to use 1 plus r over k to the k minus 1. You have that written down? Because I'm going to need you to tell me it. Okay, so what was it? It was 1 plus r over k raised to the k minus 1?
Yeah.
Sweet. Okay, so let's go through this and talk about what would the equivalent APY. Remember, the APY is going to take the rate and the number of times it's compounded, basically say what that would be as a rate if it was compounded annually. Okay? So, first off, what is her rate? 5.15, which is 10515, right? Okay, and then when we go into how many times it's compounded, that's going to be k. What is it? 4. So now, let's just plug that into our new formula for calculating APY. I'm going to do 1 plus r over k, that's 0.0515 over 4, raised to the 4th, and then we're going to subtract 1 off of it. Okay, so let's get out your calculators. Be careful with your parentheses. Plug that in. Let's see what you get. Alright, so shout out what you got here, guys. .0525, thank you. Okay, so what does that even mean? So her rate was 0.0515, and it was compounded quarterly. This is the equivalent of a rate of 0.0525 compounded annually, so once a month. So if I'm given a whole bunch of options where I have different rates compounded at different periods, I'm going to put them on the same scale to where they're compounded annually, and that helps me figure out which rate is better. Okay, let me show you one more example here. And this will kind of make sense of that, and then we'll call it good for today. Which investment is more attractive, one that pays 8.75 compounded quarterly, or one that pays 8.7 compounded monthly? Alright, so let's look at that. We have 8.75 compounded what? Quarterly versus 8.7 compounded monthly. And our formula, it was 1 plus r over k to the k minus 1, right? Okay, I'm splitting you half again. I want you guys to take the 8.7 compounded monthly. Okay, so the one on the left. And I want you guys to take the one on the, you got the one on the right, okay? You guys have the one on the left, 8.75 compounded quarterly. And what it's going to do using this formula, it will tell us what the equivalent rate would be compounded annually. And then we'll go from there, okay? All right. Hey, group on the far right, you did 8.75 or 8.7 compounded monthly. What did you get the rate is? 0.9? 0.09. So I guess I should be more precise here. So if we have 8.7%, that's really 0.087, right? So 0.087 compounded monthly is the same as 0.09 compounded annually, right? Okay, group over here, you had 8.75%, which is 0.0875 compounded quarterly. When you plugged it in the formula, what did you get? What'd you get? 0.09, exactly. 0.0904. Hey, group over there, did you get 0.09 exactly? Ooh, so which one's better? Not by much, but which one's better? The far groups, right? Because they got 0.0905. Okay, so basically, that's just a way you could figure out if you have rates that are different in different compounding periods. You can analyze them better by basically saying what it would look like if it was compounded annually. Okay? Alright, we're going to hit the pause button there, and you already have your homework assignment, right? So, the big takeaway on this, you need to be able to calculate compound interest, okay? There was some other things, if we would have time, we would have gone over, and maybe we'll get to those a different time. But for now, make sure you can do the basics on here. You are going to have a review on Friday. Friday, it's gonna be an online review in preparation for your test on Tuesday. So please make sure if you have questions that you either come in before or after school or you email me, and make sure you tune in Friday for that review, okay? Alright, great, you guys are awesome. Will you just make sure you get the calculators away and get cleaned up. Wait a couple minutes before you leave though, alright?